Hey there, students. In this video, we're going to talk about solving exponentials, solving exponential equations for a variable. Now, in order to solve an exponential, you're often going to have to do the inverse of an exponential, which is a logarithm. And so these problems actually end up being calculator problems where you get your equation in a form that you can punch into a calculator, but there's something really important to keep in mind when you're using a calculator with logarithms. So here's your reminder. Our calculators can't really handle complicated logs with varying bases. So when you need to type in logs that have bases other than 10 or e, here is a little, just a little model to keep in mind for how you would type them in. So let's say I wanted to type in log base b of a to calculate that in a calculator. The way we have to type that in is log a divided by log b. So these are the exact keys you'll use on your calculator. Log is a button on your calculator. There's actually a button that looks like this, LOG. So you'll click that button and it auto fills in the opening parenthesis. So you'll need to type in a, well, whatever a is, whatever number a is, and then close your parentheses. And then divided by, type the log button again, which auto fills that first parenthesis. And then put in whatever your base is, your b value, and then close the parenthesis. And then click enter, and that should give you an accurate value. So as a quick example, if you wanted to figure out what log base 3 of 7 is, you would type in log 7 divided by log 3. And that should give you an accurate calculation. So let's get into our first example problem. First, in this question, we want to solve the equation 4 to the power of 3x minus 2 equals 7. We want to solve this for x. So the issue is our x is up in the exponent position. So we need to figure out a way to cancel out this 4 so that brings our x down into the main level of our equation here. So the way you cancel an exponential like 4 is you do the inverse of an exponential, which is a logarithm. So to cancel the 4, we'll take log base 4 of both sides. Now, I didn't really leave myself enough space to do this, so let me rewrite this. So you'll have to take log base 4 of the left and log base 4 of the right. On the left, conveniently, actually by design, the log base 4 and the exponential 4 cancel each other out, which basically just has the effect of bringing the 3x minus 2 down to the main level. Now over here on the right, we still have log base 4 of 7, and there's not much we can do to simplify that. So moving on, our goal is still to get this x by itself on one side. That's how we solve for x. So we're just going to add 2 to both sides. And that'll give us 3x equals log base 4 of 7 plus 2. And then finally, we can divide both sides by 3. So our answer ends up being x equals log base 4 of 7 plus 2, all divided by 3. Now this is a correct answer, but it looks like they want us to actually calculate this and get a numerical answer. So time for our calculators. To type in log base 4 of 7, we're going to need to punch this into our calculator. Log parenthesis 7 divided by log parenthesis 4. And then we have a plus 2 with that as well. And that's all in the numerator of our problem. Then we'll type divided by 3. So you're going to need to actually input parentheses here as you type this in. So I've pushed, or I've written the buttons that you'll push from left to right in your calculator to get an accurate reading on this. And when you type all this in correctly into your calculator, you should end up with about 1.13-ish. All right, the second part of the problem is asking us to solve something similar, but this time for u. So we've got 5 to the negative u plus 4 equals 9. I'm going to leave space this time because I've wised up. In order to get this u down onto the main level of our problem, we have to figure out a way to cancel out this exponential 5. Well, the way we do that is its inverse, log base 5 of both sides. So on the left, the log base 5 and the 5 exponential cancel each other out because those are inverses. So we just have negative u plus 4 on the left and log base 5 of 9 on the right. Now in order to get that u by itself, we're going to subtract 4 from both sides. So now we have negative u equals log base 5 of 9 minus 4. And finally, we can multiply both sides by negative 1 to get that u completely alone. So we'll have negative log base 5 of 9 plus 4. So now it's time to type this into our calculator. When we do that, we have to be careful again because of this log. We'll type in negative log 9 divided by log 5 and then plus 4. We don't really need any extra parentheses in this problem since our fancy calculators can observe the order of operations for us. When we type all of this in, you should get an answer somewhere in the ballpark of 2.63. Question number 12 is very similar to the one we just did. We're going to start with the top example, 4 to the power of negative 2x minus 1 equals 8, and we want to solve this for x. So let's first eliminate the 4. We do that by taking log base 4 of both sides. So again, I didn't leave myself very much room. Log base 4 of the left, log base 4 of the right. Let's see if we can rewrite this a little nicer. That will cancel the log base 4 and the 4 exponential, leaving us with just negative 2x minus 1 on the left. And on the right, we have log base 4 of 8. Now, to get that x by itself, we're going to add 1 to both sides, and then divide both sides by negative 2. So I'm going to kind of shorten my steps here, save some time. We add 1 to both sides, divide both sides by negative 2. You end up with log base 4 of 8 plus 1 divided by negative 2. So when we plug this into our calculator, we're going to type in, let's see, log 8 divided by log 4 plus 1, and that's all in the numerator, so we're going to need parentheses there, and then we're dividing it by negative 2. So you might want parentheses around that negative 2 as well. And that's how you would type this into your calculator. And if you do that correctly, you should get something around negative 1.25. For the next half of this question, we want to find u when we're given 81 to the power of 3u minus 2 is equal to 3. So first we have to take the log base 81 of both sides. That's a big number. And that will cancel out with this 81, leaving us on the left with just a 3u minus 2. And on the right, we'll have a log base 81 of 3. To get the u completely by itself, we add 2 to both sides, and then we divide both sides by 3. So we get u equals log base 81 of 3 plus 2 divided by 3. And when you plug this one into your calculator, you're going to type in log of 3 divided by log of 81 plus 2, and this is in the numerator, so you're going to have to put parentheses around that whole expression, then divide by 3. When you type all of that in, you should get about 0.75. Question number 15 is a little bit different in a couple of ways. So we start out here with 7e to the 0.19x plus 8 minus 10 equals 0. Whoops. The reason this problem is a bit different is because we're trying to solve for x. So we know we need to get rid of this e. The problem is we can't start taking natural log of both sides just yet because there is a lot of other stuff going on this side of the problem that's going to complicate things tremendously if we go starting to take logs of both sides. So first what we want to do is move all this other junk over. So we're going to start by adding 10 to both sides. And then dividing both sides by 7. So that'll give us 10/7 on the right. Let me leave myself a little more space. I said I was going to leave myself more space, and then I didn't leave myself more space. All right, so now look over on the left. We have e to a power of something, and there's nothing else over there with that e. This is an ideal condition to take the log of both sides. So in order to properly cancel out e, we would have to take log base e, but we have another name for that. That's called natural log. And your button actually has your calculator actually has a natural log button, which is very convenient. We don't have to worry about all those weird calculator tricks that we have to do to calculate logs, because there is a built-in natural log, a built-in log base e on your calculator, which is nice. So over on the left, natural log and e cancel. Remember, this is just log base e of e. Those will go away. Then on the right, we're just going to have that natural log of 10/7. Not much we can do about that. Okay, let's get this x by itself. We're going to subtract 8 from both sides, and then we're going to divide both sides by 0.19. So we end up with x equals natural log of 10/7 minus 8, all divided by 0.19. And when we punch this into our calculator, it's pretty convenient because of that natural log button. We just type in ln, which I believe populates its own open parenthesis, and then 10 divided by 7. You will have to close the parenthesis, however, minus 8. And since this is all in the numerator, you're actually going to need parentheses around the whole expression, divided by 0.19. And that should get you your accurate reading on your calculator. When you type this all in, you should get something around negative 40.23. Very similar problem in question 1. We're going to be solving for t this time. And there's all this other stuff on the left-hand side of our problem along with this exponential. Actually, there's not a whole lot of stuff. There's just one thing. It's the 10. So we're going to need to divide both sides by 10 before we proceed. So that'll be e to the negative 0.13 t is equal to 4/10, which is the same as 2/5. Now, in order to continue, we are going to have to cancel out the base e, and we do that by using its inverse, which is natural log of both sides. So on the left, the natural log and the e cancel, so we'll have negative 0.13t equals natural log of 2/5. And finally, to get that t completely by itself, we're going to divide both sides by negative 0.13. So when we go to type this into a calculator, we'll type in natural log, parentheses, 2 divided by 5, close parentheses, divided by negative 0.13. There we go. And this should get you the answer, t equals 7.05-ish. Question 5 looks really, really nasty, but I promise it's not so bad. It's going to feel really ugly at first just because there's a lot of stuff going on, but if you kind of punch these things into your calculator as you go along, it's not that bad. So we are starting off with 750 divided by 1 plus 8 e to the 0.4t equals 642. We want to solve for t. Our first problem is that the t is in the denominator of a fraction. So what I want to do first is actually move it up into the numerator by multiplying both sides by 1 plus 8 e to the 0.4t. Basically, I'm just multiplying both sides by the denominator. Okay, so on the left, these will cancel, and on the right, we'll have 642 times 1 plus 8e to the 0.4t. Now I'm going to divide both sides by 642. So we've got 1 plus 8e to the 0.4t on the right, and 750 divided by 642 on the left. And that fraction obviously simplifies, but I'm going to be plugging all of this into a calculator anyway, so I'm not even going to worry about that. Let's get that t by itself. To do so, we're first going to want to get rid of the 1 and the 8, and then we can eliminate the e by taking the natural log of both sides. So first things first, let's subtract 1 from both sides. That'll give us 750 over 642 minus 1 equals 8e to the 0.4t, and then we can divide both sides by 8. So this is going to look particularly ugly because we've got fractions inside of fractions, but thanks to our awesome calculators, we don't have to worry about it too much. Now that we have this exponential all isolated, it is time to take the natural log of both sides. So natural log of the right, natural log of the left, and over here on the right, the natural log and the e will cancel. So I'm going to move up here because I'm running out of space. Now we have the natural log of this big, awful fraction. 750 divided by 642 minus 1 over 8 equals 0.4t. And the final step to getting that t all by itself is to divide both sides by 0.4. So again, we're going to have fractions inside of fractions inside of fractions. Couldn't be uglier. And to save myself a little bit of time and space, I'm just going to do it all here. I'm going to divide the left by 0.4 and then erase it from the right, just kind of pretending like I did that on the next line. So this is what we want to plug into our calculator. And it's not pretty, but let's give it a try. So here's what we would need to type. T is going to be, let's see, we'll type in natural log, which opens up a set of parentheses. We're going to need, let's see, 750 divided by 642 minus 1. This needs to be in a set of parentheses because then we divide by 8 and that whole thing is the numerator. Close your natural log and then divide by 0.4. Actually, that's not too bad. There are a few extra sets of parentheses floating around in there, but it's not as bad as I thought it was going to be. So this is what you would type into your calculator, and if you do it correctly, it looks like we should get about negative 9.65. And that was the last example for this lesson. So I hope this helps you on your homework 12.